Okay, so student, let's go through the question for the lesson 31, gravitational potential energy. So we look at the question number 1. The difference between the gravitational potential and the gravitational potential energy is, okay, so A, gravitational potential energy is a vector quantity, whereas gravitational potential energy is a scalar quantity. Is it correct or not? No, both of them are vector quantity because they have the direction. The direction is negative, right? Attraction. So B, gravitational. Okay, hold on that. Okay, B, gravitational potential refer to unit mass, to a unit mass potential, yeah, no energy, where gravitational potential energy takes into account the total mass. So that means that explain the difference. Yes, this is the difference. Okay, gravity potential refer to 1 per kg, but gravitational potential energy takes into account the total mass. So the answer will be B. C, gravitational potential in what? Hey, what is the electric? No. Okay, gravitational potential is negative, where gravitational potential energy is positive. No, both of them are negative. Why? Because they are attractive. Okay, so they are attracted towards the Earth. Okay, next we go to the question number 2. Question number 2, which of the following diagram is the correct representation of equal potential around a planet? Equal potential, that means that, okay, the magnitude will be bigger when it's nearer to the surface of the Earth. The further the object, will be the smaller the magnitude. Negative show that there is a attractive, so there is a direction. So from here, A, 6 and 7, the further is 7, that means A is wrong. Okay, B, the nearer is 7, okay, further is 6, so this one, okay, look at others. Okay, this one positive, positive, wrong, because the gravitational potential is in negative. So answer still is B. Okay, next. Let's go to the question number 3. A block of 20 kg is lifted vertically 10 meters above the surface of the Earth. The gravitational potential energy of the block changed by how many joules? Okay, 10 meters, that means that gravitational potential energy, that means change of the yield will be equal to mgh. Okay, so that means that the mass 20, g 9.81 or use 10, so h is equal to 10. So that means here sim 20 and 39, okay, 3.9. So that means that let's calculate 20 times 9.81 times 10. So that means it will be 1962. So that means it will be equal to 1.962 times 10 the power 3 joule. Okay, so from here, which one is correct? Is positive or negative? If there is a change of the gravitational potential energy, so it will be positive. Okay, so it will be positive. Why? Like that. So still remember or not, final? Okay, yesterday we learned that. Okay, so because it's negative, G M E M over radius plus with the hash. Okay, this is final, right? Minus negative GMEM over R. Okay, so this means that this negative will become positive because this is smaller, right? This is bigger, right? Bigger, that means value will be smaller. So at the end, it become positive. This one become positive minus the negative. This value will be small. Okay, small value. This will be bigger. Okay, so bigger, positive minus. So at the end, it become the positive value. So this means that the gravitational potential energy, the change of the gravitational potential energy will be in positive value at the end if we lift an object further or above the Earth's surface. Okay, let's move to the question number 4. A block of mass m on a surface of the Earth is brought to a distance of r from the surface of the Earth. Okay, a block of mass m on the surface of the Earth is brought to a distance of r from the surface of the Earth. They didn't say that r is r here, but the mass of the Earth is m and its radius is r. So this means that now the r is the the radius of the Earth. What is the change in the gravitational potential energy of the block? So now this means that the question said that a block. This is the Earth. A block of mass m is on the surface of the Earth, initially at the surface of the Earth, initially. Okay, it's brought to a distance of r. Yes.
Wang Guangyong asked you to admit him.
Wang Guangyong, ha? Okay, ada 2 orang tak pasang. Okay, so that means this object with m is brought to a height of r. Okay, so where the Earth with the mass of capital M and the radius of the Earth also will be the r, right? So from here, what will be the total distance? So total distance will be r, correct? So that means that what is the change in the gravitational potential energy? Okay, so if gravitational potential energy on the block, so that means that okay, first this will be G M mass of the Earth, ME, ME capital, ME M over how much? Over the total distance. Total distance will be equal to 2r. Okay. Okay, so this will be change of the change of the gravitational potential energy. So, and in other words, that means that this is correct, right? Okay. In other words, we also can say that this will be the mgr as well. Okay, so that means that here C and A can be accepted because there is a change in the gravitational potential energy of the block. Okay. Okay, so this means that here we have 2 answers The answer can be A. The answer can be C. Okay. Let's move to question number 5. The figure below show the variation of the gravitational potential energy. Okay, so yield of an object with the distance r from the center of the earth. What is represented by the gradient of the graph? Okay, so gradient of the graph represent the, still remember this one, if gradient of the graph represent the force of the object. If find the area under the graph, this will be the, to find the area gravitational potential of the object is the area under the graph. But this force is the gradient of the graph. Okay, next. Question number 6. The figure below shows the relative position of the Earth and the Sun. Which graph represent the variation of the gravitational potential V with the distance from the Earth to the Sun? So Earth and Sun. Okay, so what we want to find? Find the graph represent the variation of the gravitational potential with the distance from the Earth to the Sun. So now seems that the Sun pull the Earth. Because the Earth with smaller mass, the Earth will move towards the Sun, right? So that means from a distance of infinity. Okay. Okay, so this is the distance towards the, okay, towards the Sun. They want the velocity, variation of gravitational potential with the distance. So that means that when the distance is nearer, that means that the gravitational will be greater. Okay, A, B, C, D. So the answer should be A. Per kg. That means that from here, gravitational with the distance. Yes, the answer will be A. Okay, now, next. Question number 8. A body of mass m is initially at point x distance r1. Okay. From the center of the Earth, is brought further away from the Earth to a point y. Further. So distance r2 from the center of the Earth, reduced in terms of the mass of the Earth m, and the universal gravitational constant is g. R1 and R2, the expression for A, the energy required to move the mass from x to infinity. So A, what is the energy needed? Okay, from infinity, that means here find the what? Gravitational potential. Okay, so the energy required to move the mass from x to y. So that means that this one, okay, find that the change gravitational potential energy. Okay, so that means that V okay, so a gravitational potential energy. Better use the word to. Okay, to carry, to move the mass from x to y. So that means it will be like that. G capital M times with M over R1, okay, minus the G M capital M over R2. Okay, so that means that, okay, R1 is at the surface of the earth, right? So initially, which one is initially? Initially is R1, final is R2. But after, okay, after we use negative, at the end it becomes positive. So I think better I use, okay, I show that like that. It's easier. Equal to negative. In this one will be final. Final is R2 minus negative R1. So this will show that it will be equal to G M over R1 minus G M over R squared. R2, sorry. So this means that initially should be like that, but after we rearrange, it becomes like that. Okay. So at the end, what we can set that it will be G M okay, times with 1 over R1 minus 1 over R2. So this will be the derivation for this question. Okay, get it, class? Okay, now Let's move to question number 8. Question number 8. A point P and Q above the surface of the Earth are distance of x and 2x respectively from the center of the Earth. The gravitational potential at P is negative 3.2 times 10 to the power 8 joule per kg, and calculate the work done to move the mass of 2 kg from Q to P. Okay, so let's go to, as I say, to the to a words file. Let me switch on the Microsoft Words. Okay, let's go to the question number 8. Okay, so first, gravitational potential at P is given by what formula? That means Vp is equal to negative Gm over 2R. So it will be equal to negative 3.2 times let me see here. X and 2x. P, the gravitational potential energy at P, okay, given is negative 3.2 times 10 the power 8 joule per kg. And the gravitational at Q is VQ is equal to negative G M over 4R. Okay. Above the surface of the Earth at a distance of x and 2x respectively from the center of the Earth. Okay, that means that we go back to the question that said that, okay, there will be the okay, go through the back to the question. You see 2 points P and Q above the surface of the Earth are at a distance of x, okay, and 2x respectively from the center of the Earth. So that means that let's go through again the question. Okay, so if I use that x and choose x, so that means that I also can use the, okay, this one, the okay, I can write, I write it like that. First will be r e plus h plus the x, right? And this will be re plus 2x. Okay, 2 times. Is it like that or not? Let me see. Yeah. Let's go back to the question. We analyze the question a while. 2 point P and Q above the surface of the Earth are at a distance of x and 2x respectively from the center of the Earth. Okay, if center of the Earth means, wow, this object is x and 2x. Okay, let's look at the question first. Let's set that P. P above, let's say this is the, this distance is the x. For Q is higher, where this distance is 2x. Okay. So consider let's say I use an example. Okay. Let's say I use an example. This is a distance of r. This also is the distance of r. Correct or not? Okay, that means total is 2r, right? And Q for P. For Q, it should be like that. This distance is double, 2 times of x. So that means that it will be 4r. Okay, that means that more easiest for us to analysis. So that means that this we can, if we use re plus x, that means that this one we cannot use re plus 2x, but it will be 2 times of re plus x, double. Okay, so that means that this is x, this is 2x. So that means that by a distance of x, y is equal to double of x. So better, okay, better I use this example. It's more easiest for us to use the example. Total distance for P, point P, is equal to 2r. So here, double, it becomes 4r. I assume that the height is r. Okay, so we use this one, it's better. Okay, next, hence, VQ is equal to 1 negative 1.6 times 10 the power at joule per kg given. So now, difference in potential. X is radius to the center of the Earth. I didn't say that X is the center to the Earth, but X is the center. Okay, X is the center of the Earth to a distance, something like that. So we need to understand this one first. They said that the distance of x is from the center of the Earth to the object, but y also the center of the Earth to the object, but the distance is double of the x, Okay, so if okay, understand. So I use the we use this one. Maybe this one is more easiest for you to understand. So if this, we don't want to assume like that. That means that maybe it makes you confused. First, the relationship y is equal to 2x, correct or not? Okay. At P is x. At Q, there is 2x. P, there is x. Okay. Y, this should be y, but it's 2x. Okay, something like that. Okay. So from here, what will be the change of the potential difference? So change of the potential difference, delta V will be equal to delta P minus delta Q. Okay, P is lower, right? Okay, P is lower, nearer to the surface of the Earth, so it will be bigger. So at the end, I get that it will be okay. Final minus initial, yeah, use the basic concept. It will be final, will be higher, right? Q. So it will be V Q minus negative VP. So at the end, it will be VP minus VQ. VP is equal to how much? Negative 3.2 times 10 to the power at minus 1.6 times 10 the power, okay, at, okay. So VP become positive. VP become positive. That means 3.2 minus, okay, VP minus VQ. Okay, correct. It will be VP. VP is negative. So this one minus negative minus negative 1.6. So at the end, we get that it's still negative 1.6 times 10 the power at joule per kg. This will be the difference in the potential. And next, we want to find out the work done. What is the work done? Work done will be equal to mass times with the change of the potential. So that means that work done will be the easiest. We said that this will be the gravitational potential energy. So that means the gravitational potential times with the mass of the object. So it will be 2 times negative 1.6 times 10 the power at. So we get that it will be 3.2 negative 3.2 times 10 the power at joule. So that means that it is negative. Negative means that, okay, it's attract to the center of the other direction. Okay, if they didn't mention about that, that means that it will be 3/2 times 10 to the power 8 joule. If gravitational, they set the change of the gravitational potential energy. So in this case, if you write out negative 3.2 times 10 to the power 8 joule or 3.2 times 10 to the power 8 joule will do, because they didn't ask about the direction. Okay, question number 9. The gravitational field strength at two different points x and y are 9 Newton per kg and 4 Newton per kg. So respectively, determine the ratio of the gravitational potential energy at x to the gravitational potential energy at y. For question number 9. At point x, m over r x squared. Okay, where the it is equal to 9. 9 is equal to g m over r x squared. Equation 1. And at point 1. Uy is equal to g m over r y squared, where it is equal to 4. Okay, ry squared. So this will be the equation 2. Okay. So by solving the question, I use 1 equation divided by 2. That means that 9 over 4 will be equal to g m